Welcome to our channel. Today we're diving into the fascinating world of robotic engineering and exploring some of the greatest inventions of the centuries. You know, when most people think about robots, they picture those clunky metal guys from old sci-fi movies, but the reality is so much cooler. From the factory floor to outer space, robots are changing the game in ways we never thought possible. They're building cars, performing surgeries, and even exploring other planets. We're talking serious, how do they do that? Engineering here, and I'm pumped to break it down for you. So buckle up, get ready for some mind-blowing tech, and let's explore some robotic revolutions. Our journey starts back in 1961 with a true pioneer, the Unimate. Picture this, it's the 60s and the world is on the brink of a technological revolution. Enter the Unimate, this 4,000-pound robotic arm that revolutionized the manufacturing industry. It was like something straight out of a sci-fi comic book, but this was the real deal. The Unimate was designed for one main purpose: to take over dangerous and repetitive tasks on the factory floor. Before the Unimate, these jobs were often done by human workers who faced risks like injuries or exposure to hazardous materials. But this big metal arm changed everything. It could lift heavy objects, weld metal parts with incredible precision, and even repeat tasks with consistent accuracy. Now you might be thinking, okay, a giant arm that does heavy lifting. Sounds kind of basic, but hold on, this was groundbreaking stuff. The Unimate was a game changer because it proved that robots could work alongside humans in a factory setting, increasing productivity and improving safety. Think about it. This was the first time a machine could perform these tasks with such precision and consistency. One of the coolest things about the Unimate was how it actually worked. It used something called hydraulic actuators, which were basically like powerful muscles controlled by a computer program. This allowed the robot to move with surprising strength and dexterity. And get this, the Unimate even had a memory. Well, sort of. It could store a sequence of movements that it could repeat over and over again, making it perfect for those repetitive factory jobs. The Unimate's debut at a General Motors plant in New Jersey was a defining moment in history. It marked the beginning of the robotics revolution in manufacturing, and the impact of this invention is still felt today. Think about all the things we rely on that are made in factories: cars, phones, appliances. The Unimate played a huge role in making those things possible. It paved the way for more advanced industrial robots, transforming industries and changing the way we work and live. Okay, we've talked about the OG robot, but let's fast forward a few decades to the age of humanoid robots, where things get really interesting. Enter Asimo, Honda's groundbreaking creation that took the world by storm. This wasn't just another robotic arm, this was a robot designed to move and interact with the world like we do. Asimo, which stands for Advanced Step in Innovative Mobility, was like something out of science fiction, but it was real, and it was walking among us. Developed by Honda engineers in the year 2000, Asimo was the culmination of decades of research and development in the field of humanoid robotics. It was more than just a machine. It was a symbol of how far robotics had come and a glimpse into a future where robots could coexist with humans. So what could Asimo actually do? Well, this wasn't your average robot. It could walk, run, climb stairs, even dance. It could recognize faces, understand voice commands, and even interact with objects in its environment. It was like a scene from a futuristic movie, except this was happening in real life. One of the most impressive things about Asimo was its ability to walk like a human. It could shift its weight, balance on one leg, and even navigate uneven terrain. This might seem simple, but it's incredibly complex to replicate in a machine. It required advanced sensors, gyroscopes, and sophisticated algorithms to mimic the fluidity and balance of human movement. But Asimo wasn't just about walking and talking. It was designed to interact with humans on a personal level. It could recognize faces, respond to gestures, and even engage in simple conversations. This ability to interact with humans in a natural and intuitive way was a major breakthrough in humanoid robotics. Asimo wasn't just a technological marvel, it was a cultural icon. It appeared on TV shows, met world leaders, and even rang the opening bell at the New York Stock Exchange. It captured the imagination of people worldwide and sparked a global conversation about the future of robotics. Okay, we've seen robots transform factories and walk among us, but how about exploring other planets? That's where the Mars rover comes in. This robotic explorer is straight out of a sci-fi adventure, and it's been sending back incredible data from Mars for years. The Mars rover is a perfect example of how we're using robots to push the boundaries of exploration. It's like having a remote-controlled scientist on another planet, and it's been making mind-blowing discoveries about our celestial neighbor. Think about it, we're sending robots to places humans can't yet go, and they're sending back valuable information that's changing our understanding of the universe. So, what makes the Mars rover so special? First off, it's built like a tank. It has to be tough enough to withstand the harsh conditions on Mars, extreme temperatures, dust storms and rough terrain. It's like a high-tech off-road vehicle designed for exploring another world. But the Mars rover is more than just a tough cookie. It's packed with scientific instruments that allow it to analyze rocks, soil, and even the Martian atmosphere. It's like a mobile laboratory on wheels, and it's been making groundbreaking discoveries about the red planet. One of the most exciting things about the Mars rover is its ability to rove, to move around and explore different areas. It's not just stationary, it can travel across the Martian surface, collecting data and sending back incredible images. It's like having a live feed from another planet, and it's absolutely captivating. And remember those cool images of the Martian surface? Those are thanks to the Mars rover's incredible camera system. It can capture high-resolution images and even panoramic views, giving us an unprecedented look at the red planet. It's like taking a virtual tour of Mars from the comfort of our own homes. The Mars rover is a testament to human ingenuity and our thirst for exploration. It's a shining example of what's possible when we combine cutting-edge robotics with our desire to explore the unknown. Alright, remember how I mentioned robots doing things we never thought possible? Well, hold on to your hats because Boston Dynamics Spot is here and it's changing the game again. This robot dog is not only super advanced but also incredibly agile and versatile. Spot is like the Swiss Army knife of robots, capable of tackling a wide range of tasks, from inspecting dangerous industrial sites to assisting law enforcement. It's like having a super-powered canine companion that can handle the tough jobs, all while looking like it stepped straight out of a sci-fi movie. One of the things that makes Spot so impressive is its incredible mobility. This thing can move, it can walk, run, climb stairs, navigate uneven terrain, and even recover from being pushed over. It's like watching a real dog, but with even more agility and stamina. But Spot's talents don't stop there. This robot dog is packed with sensors and cameras that give it a 360-degree view of its surroundings. It can create detailed maps of its environment, detect obstacles, and even identify potential hazards. It's like having a walking surveillance system that can go places humans can't. But wait, there's more. Spot can also be customized with different attachments and payloads to perform specific tasks. Need to inspect a bridge for structural damage? Attach a high-resolution camera and let Spot do the climbing. Need to transport heavy equipment across a construction site? Equip Spot with a cargo carrier and let it handle the heavy lifting. And the best part? Spot is designed to work autonomously or with a human operator. It can follow pre-programmed routes or be controlled remotely, making it incredibly versatile for a wide range of applications. It's like having a robotic teammate that can adapt to any situation. Spot is a prime example of how far robotics has come and a glimpse into the future of how robots will work alongside us. It's a testament to human ingenuity and our ability to create machines that can push the boundaries of what's possible. We've seen robots made of metal, robots that walk and talk, but get ready for this. Robots made of soft, flexible materials. That's right, we're talking about soft robotics, and it's one of the most exciting and rapidly developing areas of robotics today. Imagine robots that can squeeze into tight spaces, gently handle delicate objects, or even adapt their shape to changing environments. That's the promise of soft robotics, a new generation of robots inspired by the flexibility and adaptability of living organisms. Now, you might be thinking, robots made of soft materials? How can they be strong or precise? Well, that's where the ingenuity of soft robotics comes in. Instead of relying on rigid skeletons and motors, soft robots use flexible materials like silicone, rubber, and even fluids to move and interact with their environment. One of the coolest things about soft robots is their ability to deform and adapt to their surroundings. They can squeeze through narrow openings, conform to irregular shapes, and even interact with delicate objects without causing damage. It's like watching a robot made of Play-Doh, but with incredible precision and control. But how do they actually work? Well, soft robots use a variety of actuation mechanisms, from pneumatic and hydraulic systems to smart materials that change shape in response to stimuli. For example, a soft robot arm might use compressed air to inflate and deflate its segments, allowing it to bend and grasp objects with surprising dexterity. Soft robotics is opening up a whole new world of possibilities for robots. Imagine surgical robots that can navigate through the human body with minimal invasiveness, or robots that can assist with delicate tasks like picking fruit or handling fragile objects. The potential applications are limitless. And the best part? Soft robots are inherently safer to interact with humans. Their soft, compliant bodies make them less likely to cause injury, making them ideal for applications where robots and humans work closely together. Thanks for watching. If you enjoyed this video, make sure to like, subscribe, and hit the bell icon for more amazing content on the latest in technology and engineering. We've journeyed from the factory floors to the surface of Mars, witnessing firsthand how robots are changing the world as we know it. But this is just the beginning. As robotic technology continues to evolve at an astonishing pace, who knows what incredible feats of engineering we'll witness in the years to come. One thing's for sure, it's an exciting time to be a robot enthusiast. So keep that sense of wonder alive, stay curious, and let's embrace the future of robotics together. Until next time, keep exploring.